Most SwiftUI login tutorials stop at the UI. This one doesn't. In this video, we'll build authentication the right way, state-driven, scalable and ready for app signing or even Firebase signing without rewriting your app. Clean architecture, clear boundaries, no hacks. We now need to create our protocol for session storing. Create a new empty file. And then rename the file as session storing. Then we create our protocol session storing, which will include the following: function save, user, app user, function load, user that will return an app user, function clear throws. So the view should never care where auth lives. This gives us a clear swap later, such as we can use the keychain, a backend tokens, or whichever provider you want to use. So the next thing we need to do is to create another new class. Name the class user defaults session. It should be session store. Import foundation, create our class, private let key will be author user. This is just for demo purposes only. Real auth should not live in user defaults. This is purely to keep the tutorial focused on architecture. As you know, if you want to store sensitive data, you should really use the keychain, which I've done in previous tutorials. So now we have to implement our stubs. So for the first one, that is save. Which will obviously save a user to the user defaults. I think I deleted the variable that I created earlier. Don't know how that happened. Auth user. As we need a key as a parameter to pass to user defaults. The next one is to load the stored user, retrieve the stored user from user defaults. seems like app user needs to be optional within our protocol. So let's go back to app user within our session storing protocol. So for load user, that should be optional. And for the load user, how it's returning app user, that should be optional also. And then to declare user defaults, we just need to type in the following: user defaults, remove object for key. Let's compile it. The next file we need to create is our auth service file. This is actually our class. We need to import the foundation. And I'll just copy and paste the code from the clipboard to reduce the length of the video, and then explain the code. So there's a few things missing. Auth error, which should include invalid credentials and session save failed. So let's implement those now as well. Just create another new file and name it auth error. Implement the following: import foundation. That should be foundation. Auth error will be an enum, which will implement the localized error. And the cases we'll be capturing will include invalid credentials, case session saved failed. And then using this property, we just display the actual error that happened. So that should be invalid email or password. And for the other case, it should be could not save session. Now just go back to the other file we're working on, which is this one. So now it should compile. It must be a spelling mistake in the It's probably a spelling mistake. So that should be session saved failed. Cannot convert value of type string to expected argument type. So app user should be a string, not a UID. Let's compile it now. So this class, author service, is thin on purpose. Later, this becomes Apple sign-in, or a mixture of Apple and Google sign-in using Firebase, and the rest of the app doesn't change. On lines 18, we simulate a real-world keychain token refresh. Although at the moment we're using user defaults, but in the real world it will be the keychain. And on line 25 we also simulate a network latency so that it assumes, or it looks like, that the actual request is being performed from a network. And this is done using this constant here with nanoseconds and sleep and task. We also include some fake validation. Since this video is about architecture, we're not building a secure backend, so we just implement some fake validation on lines 27. The next file we need to look at is our app file. I'll just copy and paste the code from the clipboard and then explain it. We don't need any previews. On lines 12, the all-view model is created once at the boundary. The app boundary, this is a single source of truth for the session state. And then we also have our dependencies, which are composed explicitly here. App boundaries equal dependency graph roots. And we inject our dependencies manually. And this avoids hidden singletons. On lines 29, the environment injection happens once at the top. Everything below consumes state, nothing recreates it. On lines 32, the auth state must be resolved before the UI continues the branching. So this is our form of the application for the actual navigation. Now let's run the application. And this is what you should do anyway. And then you can attempt to log in.